welcome our viewers, and as members we are requesting that we begin with the topic about vectors, that is mathematics, Senior 3. So Senior 3 and Senior 4 students, this lesson can have you covered. Mr. Hyper, and members, I would request that as you view this or as you watch this video, first subscribe. Members, you can comment in case anything is not clear or in case everything is clear. You let us know. That one gives us energy. So members, we are beginning with vectors, and the main point we are going to be looking at collinear points. And collinear points are those points that lie in a straight line. So it means that you're given a certain set of points, usually 3 points, and they always tell you to prove that these points are collinear. One may come out and say, but Mr. Teacher, you say collinear points, but I don't see the word collinear in your question. Our example is having a question using vectors show that points P, Q, and R lie on a straight line. So fellow students in class, the moment we say points lie on a straight line, it means that points are collinear. In other words, the word lie on a straight line is a synonym or is another word to mean that these points are collinear. So if the question is about collinearity or points lying on a straight line, treat it the same way. Let us see how this question can easily be attempted. Well, we are having points P, Q, and R. So it's better you first draw that line. This is my solution. I'll first draw my line, and my line will have point P, my line will have point Q, and my line will have point R. My point P is having -4 and 1. My point Q is having a coordinate 0, 2, and my point R is having a coordinate 8, 4. That is what we are having. Now, I need to tell you the conditions that make points appear to be in a straight line. For points to be in a straight line, the conditions you have to test for, we need it first to show that there exists a common point. So we shall need to talk about a common point. And another thing, we need to show that those selected points are also parallel. Now, for points to be parallel, we shall realize that there is some scalar, or there is some value, which we call a constant, that you multiply in another point in order for those lines not to meet. Now, when you look at P, Q, and R, it means that you can pick point PQ. Here we can pick PQ, you can pick QR, and you can pick also PR. So we can pick this. But any points that you use here will work out. You just need to select any 2 points. So you're having PQ, QR, and PR. So any 2 points that we shall select here will give us the answer. For example, I may use PQ. I need to first find PQ. Point PQ is the same as, by vectors, one student is reminding me that we have OQ minus OP. That is a good reminder from, he has reminded me that it is OQ minus OP. And our OQ, that is point Q, it will be 0, 2 minus point OP, which is -4, 1. From the little work we have already covered, we can deal with this vector Very well. We are going to add this column vector, and it's going to be 0 minus negative 4, and this one will be 2 minus 1. So we shall have 2 minus 1. This one will make my vector PQ to become 0 minus negative 4. This one will make a plus, and this one will become a 4. It will be 0 plus 4, which is 4. Some students normally make mistakes and they say 0 plus 4 is 0. But Mr. Listener or Madam Listener, when you get 0 plus 4, you get a 4, and 2 minus 1 gives a 1. Now, after getting PQ, I can assume that I can make my common point to be P, and maybe I can select and get PR. However, also someone can decide using PQ because it has also gotten a common point Q when you consider it with PQ. So one can use QR. Now, I can decide using PR, and point PR is the same as OR, the position vector of OR. And when I say position vector, meaning the vector of the point from the origin. So we have OR minus OP. I'm having OR minus OP. Now, the position vector of R is 8, 4. So here we shall have our 8, 4 in column form minus OP. Our OP is negative 4, 1. Negative 4, 1. This is the same as 8. We shall be having 8 minus negative 4. And this will be 4 minus 1. When you look at this, if you have 8 minus negative 4, this one will make it 8 plus 4. 8 plus 4 will give us 12. And 4 minus 1 will give us a 3. Now, you have gotten point PR. In other words, or in short, we have P2, which we've gotten as 4, 1. We have PR, which we've gotten as 12, 3. So now, we can easily see that there is a common point between these two, P2, PR. Let me ask my class, P2 and PR, between those 2 points, where is a common point? What do we have as a common point? Very excellent. He has answered that the common point is P, because here we have P2 and here we have PR. So the common point is P. Now, if we have a common point as P, that is the first characteristic of these points to be collinear. But then we have to prove that they are parallel. How do you prove that they are parallel? When I say parallel lines, these are lines that do not meet at any point. One line is like this, another line is like that. They are not meeting because of some situation or because of some condition that we are going to prove. Now, for these lines to be parallel, we shall prove that P2 is equals to K PR. K PR. Whereby my K is a constant. Now, P2 is 4, 1, and PR, so we shall say K, then PR. My PR is 12, 3. Critically, you can see, you can try solving for this value of K so that you get that constant. Now, this will be 4, 1 is equals to, this times this is 12K, and this times this is 3K. I want us to distinguish, or I want us to differentiate between a vector and a fraction. If it was a fraction, that constant would be multiplying only in the numerator. But when it is a vector, it multiplies in the numerator and the denominator. Actually, they are not called denominators and numerators. It multiplies in each entry or in each value. So that one makes it 12k and this one makes it 3k. Now, to solve for them, I can say for this one, you can easily see that 4 is equals to 12k. And when you divide through by 12 both sides, if you divide through by 12, you are going to find that that component will give you k as a third. And still, when you compare here, you're going to find out that the 3k is equals to 1. So k is equals to a third. Now, this one in vectors, we call it the component of I, and this one, we call it the component of j. Implying that the component of I, when you consider I, the constant gives you a third, and when you consider j still, the constant gives you a third. So, we are going to conclude and say that since k is equals to a third, alright, for all unit vectors, then that one means that PQ is parallel to PR. PQ is parallel to PR. And since P, because our P is a common point, since P is a common point, what does it imply? Since P is a common point, then, alright, then points P, Q, and R are collinear, or lie on a straight line. In that case, I will have proved to the examiner that points P, Q, and R lie on a straight line or they are collinear. Also, when one reaches here, another student after reaching here, after getting PQ and PR, another student can say PQ, we've gotten our PQ, we've gotten it as 4,1 is equals to, here you can see that you can factorize out a common figure so that they are the same with this. So if you factorize out a 3, it will keep here. When you factorize out a 3, it means that now you'll be dividing. So it will be 12 divided by 3, so you'll be having 4, and this one will be 3 divided by 3 that you put out, here it will be a 1. What does it imply? This 4,1 was initially PQ, so it means that PQ is equals to 3 times this. Rather, sorry, you would realize that if one is to bring out very well that aspect, it would mean that this PR is equals to 3 times PQ. Why? Because to get PR, there is what we multiply in PQ, which is 3. Alright. So still, this case would make it, or would make these lines parallel to each other. Because to get PR, there is what you multiply in PQ. And what do you multiply there? 3. How do you get a 3? After factorizing PR. So that way, you would have shown that points are collinear. To summarize it out, to summarize it for you, if you are told to show that points are lie on a straight line or are collinear, you need to show that those points you're considering have got a common point. Another thing, you have to bring in the parallel issue or the parallel idea, so that these marking points are the ones we are targeting. Then, if it is PQR, pick a set of points and consider 2, which 2 can easily be obtained and which 2 have got a common point. That's why I consider the PQ and I consider the PR. Then, by having a common point P, that is the first qualification for them to be collinear or for them to lie on a straight line. Then, for them to be parallel, that is why I went through all these steps. I have to show that to get PQ, there is something we multiply in PR, and that something, I found out that it is a third after equating the corresponding unity vectors. And then this conclusion is very important and crucial. One may be like, these words are very many. No, they are not very many, because you are describing what you have gone through, the processes that you've gone through. You found that K is a third for all unit vectors. Then it means that PQ is parallel to PR. And also you found that since P is a common point, now all those conditions are concluded within here. You've summarized them here. So this conclusion will carry a mark on someday. So thank you so much for listening. We shall meet one another in another example that will involve a drawn diagram to interpret, and then we find or we show whether points also are collinear. Thank you for listening.